Hi, welcome everybody. Happy Heat Pump Water Heater Day.
Yay.
Hopefully at the end of this session, you will be equipped to be a heat pump water heater superhero. And your secret weapon, your ace in the hole for really getting energy savings is going to be Central Heat Pump Water Heaters. And today we have an amazing panel that are going to help you in application of these new technologies. So application and design and installation are key to getting your energy efficiency savings. So with that, I'd like to introduce our guest speakers. Helen, can you show the slides? I'm not seeing them.
Oh, is anybody seeing them? I am
Yes.
sharing them.
Yep.
Yeah, okay.
Everybody but Kashmir is seeing them, I think.
Okay. And then we have a couple people. Okay, they're hearing. Okay, so good, great. So why don't we start with Nicole? Give an introduction to yourself.
Sure. I'm Nicole Ceci. I'm a principal mechanical engineer with Stephen Winter Associates based out of our New York City office, serving kind of the Eastern Seaboard, and work a lot in cold climate heat pump applications.
Wonderful. Thank you, Nicole. And Nick, you're next.
Hi, everybody. My name is Nick Young. I'm with the Association for Energy Affordability. I'm Director of Zero Carbon Buildings. I do a bunch of different things at AEA around building decarbonization, heat pump water heating, grid-friendly building design, envelope leakage testing. I've been with our West Coast office since 2014, but I'm actually moving to New York, and I'm going to be joining the New York office next week. So my life is in a bit of disarray at the moment. So forgive me if I seem a little disheveled, but I'm happy to be here.
Thank you for joining us. John, can you please go next?
Sure, and I just want to mention Nick gave a really great presentation yesterday to the NIA Product Council that is, I believe there's a recording of it available, but a lot of great information about this technology that people might check out. So I'm John Heller, president of Ecotope. I have been helping to lead the commercial working group of the Advanced Water Heating Initiative as a technical lead. So that's I have a big focus on commercial heat pump water heaters in the last several years.
Lovely. Thank you, John. And finally, Rand, will you please introduce yourself?
Sure thing. I'm Rand Conger. I am a principal here at Johnson Barrow. We're a mechanical equipment HVAC rep in the Seattle area. I was, to give credit where credit was due, basically drug into the world of heat pump water heaters by John's company about over a decade ago. And it's become a fairly significant portion of our business since, in which time we started with one product line and now have multiples in this realm.
Wonderful. And I should have given a brief introduction to myself. My name is Kashmira Engineer, and I am the Emerging Tech Program Manager at Bonneville Power Administration. I also work with NBI and lead the AWHI Commercial Heat Pump Water Heater Initiative. So thank you everyone for joining. Helen, will you move to the next slide, the slide with the questions? Okay, so I'm assuming we're on that slide. I can't see it, but I'll just roll with it. The outline for the presentation today is that I'm going to ask some questions to the panelists to get their opinions on these issues. And then also at the end, I'm going to leave some time. Helen is monitoring the chat. If you have questions, please put them in the chat. Or raise your hand, and there'll be time hopefully during and at the end of this presentation to kind of cover audience questions. This presentation is set up for you guys to make sure you are equipped to be able to understand the application of this new technology. So please participate. Okay, first question. What do you think the biggest barriers to widespread adoption for, besides cost, widespread adoption of central heat pump water heaters? Who would like to take that question?
I have an answer.
Okay, John.
I've got one, and that is, I believe, system complexity and the way that the products are delivered to the market. I believe that to become very widespread, these have to be dead easy, dead simple for engineers and installers to get installed correctly. And that means that they need full support from the supply chain to provide design support, field installation support, training, certification of contractors, wraparound warranty services. It has to be delivered in a way that other complex systems are delivered, like VRF, for example, where VRF is an extremely complex system, but it has become the easiest system for mechanical engineers to install, design, and for contractors to install in big buildings, because it comes fully engineered, as there's only one way to do it, and the supply chain helps you every step of the way. So I think getting over that hurdle in development of this product will enable it to go big.
Great, thank you, John. That's one of the principles that we would like to see in the AWHI commercial group, is a plug and play type of system. So thank you for bringing that up. Anyone else?
Yeah, I'd like to touch on, I won't talk about cost, but operating cost. So I'm sneaking money in here. Working in New York City, you can't get around this. Our cost of gas per BTU for most of my clients in New York, it's about 1/5 the cost per BTU for electricity. And when you're comparing a heat pump solution to a gas-fired solution, you don't see a 5-fold increase in COP. And so you end up in the vast majority of projects that we look at where a heat pump solution is going to cost you more on your energy bills than a gas-fired solution is going to. And that's just a huge, huge hurdle for us. That kills so many projects. It's extremely hard to make an argument to a client that they should drive their utility costs up to, do what's right for the planet. And some of our clients do decide to do that. For some of them, there are non-energy benefits that push them in that direction. But for a lot of them, that ends the conversation right then and there.
Thank you, Nicole. That's a really good point. It kind of shows our geographical differences. We're lucky here in the Pacific Northwest with very nice electricity costs.
You are very lucky with your very cheap hydropower. Yes, I would agree with that statement. I'll sort of echo what Nicole said about operating cost, and also add experience. There's sort of the like chicken and egg problem that folks are sometimes reluctant to do, particularly contractors are sometimes reluctant to do work that they've never done before, but if they are reluctant to do it, then they never do it. And so I see that we're at the early part of the adoption curve of central heat pump water heating as for the market as a whole. And at some point we will hit the inflection point, just like we're starting to see with electric vehicles, and it's really starting to sort of it's starting to trend in a very different direction, and it will happen with central heat pump water heating, but we're just not there yet. And so experience, I think, is a major barrier right now. There just are not a lot of experienced designers. We have some of them, some of the few on this call right now, but there are not a lot of folks with deep experience doing this work, either on the design side or on the installation side. And so kind of trying to get there's just a lack of experience in the marketplace. So things like this to try to like spread this information and get this knowledge out of all of our heads and into the marketplace and into everybody else's working playbooks is really important.
Thank you, Nick, very much. Rand, did you want to weigh in? I don't want to.
Sure. Yeah. No, I have a couple thoughts here. One, I see in the comments Bill Lyons identified increasing building electric power. In other words, if you're putting in a electrically powered device for creating hot water and you're supplanting gas, all of a sudden now your power requirements in that building are going to get quite a bit higher. And that is absolutely the case. What we have seen recently is development of products that can do both your cooling in the building as well as your hot water heating to try to address that. In other words, if you've got a big compressor load in your building, well, to power your chiller, well, you can supplant that with a device that can provide chilled water as well as domestic hot water or even heating hot water. Those are fairly very specific applications, but that is something that is out there being developed. I'd also just like to say that one of the big things that we're seeing that's an issue across the industry, not just for these systems, but does impact these systems, is the phase outs of different refrigerants that are coming. Not only with the ones that are currently scheduled, but then concerns about PFAs in the replacement refrigerants that are coming into place. So what we as on the equipment side are seeing is a lot of unsettledness in the industry of trying to determine what particular refrigerant or what particular technology they want to move forward with in the development of these products. So that's another thing that's kind of holding some of this development back.
Mm-hmm.
Thank you. I'm glad you brought up that point. And I did see a flash in the chat. I don't see them all, but somebody did note about CTA 2045 or EcoPort. That is correct. That is a widget that we can use on central heat pump water heater systems and, create kind of a thermal battery to hopefully help with operational costs of operating the electric equipment. So thank you. And I think that kind of nicely transitions to the second question. What can we do to kind of bring down those costs, right? So I took the easy one, CTA 2045. You guys, and Rand, you mentioned it on your last one, so maybe you get a pass here and get a go first. How's that?
Sure.
And everyone else has to clean up.
So what are things that can bring this down? The adoption, or bring down the cost, or remove these hurdles. One, I think, is basically getting more competition into the market, right? For a long time, at least in our market, there was really only one manufacturer who was making products specifically designed for this application. And in the decade or so since that was the case, many more competitors have moved in. That certainly has brought down the cost. What we're seeing now is the market has gone global in a lot of ways, in that we are seeing products come in from Europe and Asia that wouldn't have really played much in this market even 15 years ago. You just didn't see that same level of involvement from overseas manufacturers. So I guess from the standpoint of equipment rep side, that feels like a major thing that's happening in the industry to help bring these prices down.
Thank you. Really good points. Thank you, Rand. Who'd like to go next?
I'll go ahead, Nick.
Sure. I was just going to build a little bit on the idea of like a equipment in terms of like when you have additional equipment options, not just in terms of competition from different manufacturers, but also like more options in terms of it's, you know, some of our early options, they were sort of all just different versions of kind of the same thing. Whereas now we're starting to see like very different form factors, very different refrigerants. You know, I keep waiting for the day that we can use R290 refrigerant. And, you know, that'll be when we have both different refrigerant options, different manufacturers, different form factors, and we're not all just like cobbling together the same sort of 3 heat pumps for every plant we build. Then we'll actually be able to bring costs down because there will be competition, and we'll be able to actually choose the most cost-effective approach for each project, as opposed to like, well, we only have 3 options, so which of our few options are we choosing from?
Sorry, John, did you want to
No, you
build
go
off that?
ahead,
Because I
Nicole.
want to take this in a slightly different direction. So if you have anything to build on that, you should go first.
Well, I was just going to mention that there's ways to, I think that we're going to find ways to simplify and streamline the design of these systems over time. I think we've added some complexity because of weaknesses of the early equipment, and I think we're going to see high performance designs returning recirculation loops to the primary storage to eliminate that secondary loop tank that we're currently is kind of standard. I think that there's a way to use unpressurized non-potable storage instead of rated potable tanks for the thermal storage that could bring cost of the storage component down quite a bit. I think that the way that it's delivered to the market as a fully prepackaged product, like the way that the water drop product is delivered to the market, where there's no site work. It's just dropped on the roof and the plumber connects the pipes and the electrician connects the wires. I think that has the potential to significantly reduce the cost and risk and potential reliability of these systems. So I think that the market is still developing, and that will bring prices down.
Thanks, John.
I think that's the direction you have to go in. Working in New York City, I don't work with any buildings where a giant skid can be brought in and dropped in easily. And for context, I'm working mostly in multifamily retrofits in New York City. So that's kind of the building stock that any of my answers are typically referring to. So yeah, bringing a big old skid into the middle of Manhattan is not an easy undertaking. But I do think that that's the kind of form factor and plug and play option you need to have like any kind of competitive leveling with the business as usual options. And the flip side of that statement is that doing a central heat pump water heating plant today requires a ton of work. Like there are a lot of pieces in that system. There are a lot of pieces that have to be messed with. And at least in the market I work in, the business as usual that we're often competing against is like a big old Scotch Marine boiler in the basement for your heating system that just has a tankless coil in it for domestic hot water. A tankless coil is like the simplest, easiest, cheapest thing ever for making domestic hot water. And competing with that is really hard to do. So you do need a really simple solution, but frankly, I'm not sure if those are going to be able to compete on a first cost basis ever. And so I don't think we can have this conversation without being like pretty transparent about the need for incentives, at least in certain markets, for a very long time.
I wanted to just raise a few questions that have been coming up in the chat. One is related to the first operating cost issue. So the question is the first operating cost issue related primarily to existing buildings or also to new construction where new gas service infrastructure risk costs are offset?
Yeah,
Who'd like to take that? Nicole?
Sure, I can start with it because I'm the one that often complains about operating costs. In our market, it's pretty applicable to both. We have had high performance new construction projects that have done pretty thorough costing out of, do we put in that extra gas line and use a gas water heater, or do we go with a heat pump option? It's not exactly a slam dunk either way, but a lot of them end up finding that the first cost of the gas system is, even with that new gas line, can be cheaper. The operating costs are what they are. I mean, when you lock in with the utility companies in New York, the rates that you're going to get just tend to be really unfavorable to using heat pumps as opposed to a gas-fired plant.
Thanks, Nicole. A couple of other questions. Examples of market-ready systems that do both water heating and cooling.
Rand?
That sounds like a leading question. And to be fair, let me just state that this product that we're talking about has created its first production unit, and it is operating, or is actually being shipped to an operational site right now. So we're talking pretty early in development, but we do represent a product that it's a CO2 based heat pump system that is inherently simultaneous heating cooling. The standard application would be air source. It has heat exchangers available to provide chilled water, has heat exchangers available to do hot water for heating and domestic hot water, and comes in a single package, and is self-balancing. It does simultaneous heating and cooling, but self-balances through its own little refrigeration circuitry, coming in basically 30, 60, and 90 ton modules that may go up to 120 ton modules. So this product does exist. Additionally, there are other things that are more traditional. I just recently learned about call it a parallel heat exchanger that's available on a particular manufacturer's air source chillers that will provide a very significant portion of, sometimes chillers have been equipped with de-superheaters, which take out about 10% of the superheat in the compression cycle and use that, typically applied to domestic hot water. There's a product out that at least one of the manufacturers I represent, and probably others represent, that is a parallel heat exchanger that sits in parallel with the condenser coil in a air source chiller that can provide much closer to 40 to 60% of the cooling capacity as hot water, and can directly apply that in. So there are specific products that are designed to do the simultaneous load. There are products that are sort of, let's just call them enhancements to existing technology that can do that. And additionally, there's a whole line of, or a whole series of manufacturers that produce simultaneous heating and cooling chiller or heat pump products, which are usually designed, intended for the comfort heating and comfort cooling, but with a interposing heat exchanger could certainly be used to either provide domestic hot water, or usually maybe not finish that, because typically those don't get to the temperatures you need for storage of hot water, but at least address some of the load in the domestic hot water system. So there's a bunch of different products out there that already exist, as well as, again, the one product that I'm referring to that is specifically designed for this particular application and provides cooling performance as well as domestic and comfort heating.
Kashmira, can I answer that that leads us into the next question for the panelists?
Sure.
Which is there are products designed specifically for this that are being sold in Europe that will provide space heating and domestic hot water and space cooling from a single monoblock package. They happen to use propane R290 as the refrigerant, so we can't buy them here. But they are being designed and sold, and that I think is one of the biggest opportunities to expand this market in the US that is not getting as much attention as it needs to get, because we need to be able to get those products, and the US manufacturers need to be able to build and sell compressors using hydrocarbon refrigerants in outdoor equipment, because those refrigerants are inexpensive, very efficient, operate down to very low temperatures, and can use existing compressor technology. So making hydrocarbon refrigerants legal in HVAC equipment in the US is a huge opportunity, and also a cost reduction opportunity that should get more attention.
Thank you, John. Helen, is there another question in the chat that's related, or should we move on?
I think we can move on. I'll save some questions for later.
Sounds good. Well, so what do you think the biggest opportunity is to advance the central heat pump water heater market? What should we be focusing on? Who'd like to take that?
I already went, other than R290.
I'll in the spirit that Nicole sometimes brings to these discussions of sort of taking things a bit left field. I'm going to say we should not forget about utility rate proceedings, because all of this can be totally derailed if the utility commissions and the utilities in where you're operating set gas and electric rates in a way that like totally crater the economics of these projects. And so like we tend to be very focused on like the engineering and the heat pumps and the refrigerant and the piping and like all that stuff. And like that's like those are the trees, but the forest is like the utilities and power and how much this energy costs. And I think we need to pay attention to that stuff and be engaged in these, or at least know who is engaged, and make sure that like as an industry we are engaged in like utility rate proceedings, and that like we need to make electrification beneficial for people. It needs to be a slam dunk other places than just the Northwest. And so like, how can we make that happen? I think that's an opportunity. Like if we could find a way to like as a society to, like in California, in New York, in other places where gas is cheap and electricity is inexpensive, to flip that in some way, or at least like move the needle a little bit in the other direction, it would all of a sudden the economics of these projects would be very different.
Yeah, you're hitting on a big issue, which I think is policy, right? I mean, that's what it comes down to, and to I'd love to take credit as being a great salesman for these products and really building this market, but it really did help when the city of Seattle essentially outlawed gas for this particular application. So I mean, that there is absolutely a huge role for policy in the adoption of this this stuff, and not just in what you're talking sort of the carrot side, but there's also the stick side too, right? And some of that is, probably, based on the overall politics of this nation, that isn't ever going to happen in certain parts of this country, at least not in the near future. In other places, it may very well happen very soon. So I think part of it is keeping an eye out for what's going on locally in the policies that affect your area, and making sure you understand what the economics of those decisions are too.
Thank you, Rand. Would you like a bite of the apple, Nicole?
Sure. I saw this come up in the chat a little while ago. I haven't caught everything, but somebody did kind of mention carbon taxes. And New York City, we have Local Law 97, which they won't call it a carbon tax, but guess what? You get fined if you emit too much carbon. Kind of effectively the same thing. That has generated a ton of interest in heat pump technology in our market. I can tell you, we've studied hundreds of buildings and put together decarbonization plans for them within the lens of Local Law 97. The fines are important. They're often not enough to even make these project economics look attractive given our utility rates. But it has been a huge driver in getting people talking about heat pumps, getting people looking into them seriously, getting people at least thinking about a long-term plan. It's not quite enough, but it's also being iterated on. It's being updated. Rules are being made. That policy is changing. And at least that's one thing that our market is doing to essentially try to counteract our really unfavorable utility rates.
Thank you. That's a good point. I like that. Got to work both sides, the carrots and the sticks, as Rand said. Okay, Helen, is there any questions you'd like to pose?
Well, there's just a few catch-up questions. I mean, the question about propane being the issue is due to flammability.
Correct.
Okay.
But I would point out that we pipe explosive gas into most of our buildings already with zero safety valves to keep your 6-year-old from turning on your gas stove and walking away. The way that we treat enclosed small volumes of propane in HVAC equipment compared to the 5-gallon cylinder that you throw in the back of your car and to fill up your barbecue. I mean, it's ludicrous, the level of concern of safety associated with equipment, especially if it's installed outdoors. Next year 100-gallon propane tank. There's ways to do this. We've trained HVAC contractors not to smoke cigarettes when they're fixing gas furnaces. We can train HVAC contractors not to smoke cigarettes when they're fixing heat pumps.
Good points. Good points.
There was another question related to clustered centralized systems, and how about moving toward clustered centralized systems without the need for recirculation serving 4 dwelling units, therefore reducing the installed cost of a commercial heat pump water heater system and maximizing operating savings.
Lots of room for innovative design solutions.
And I know that's a little contrary to what we said, where we're like, we don't trust the design solutions. So that's why we're having this seminar. But there is some evolution that still is available, right? So continuous improvement, that's what we're looking for, and avoiding pitfalls along the way. So I'm going to move to the next question. Who do you think is the most important group to educate about central heat pump water heater systems? Or another way to say it might be, who are we at risk for success if we don't educate them? And what's the best way to reach those people?
Rather than educate, I would frame it as support. And I think we need to support the people who are actually building these systems. Like John started out talking about the way that VRF is supported in the marketplace, like it's very easy for a contractor to install a VRF. Well, it's not easy, but like they have support from the manufacturer. There's a lot of resources available to them. We need to provide those same resources to these contractors who are installing these systems, because being a contractor is hard. Like it's extremely competitive. There's a lot of downward price pressure on these contractors, and they're used to doing what they're used to doing, and that's how they've built their business. And a lot of these are small businesses owned by a sole proprietor, and like it's a risk for them to try installing something that's very expensive and very new. And we can't just sort of say, yeah, go do this thing that you've never done before, that we know how to do but you've never tried. Like we're going to have plumbers go out of business because they're going to have warranty claims that they can't afford to support, because they weren't adequately supported in the building of these systems. Mistakes were made. There's too many callbacks. And like we can't afford to decarbonize this industry, or like decarbonize water heating on the backs of all of the plumbers who are building these systems. Like I think it's critically important that we, as the like design industry and like consultants and programs and manufacturers, that we support the people who are actually building these systems and provide them with the resources to be successful and to like actually make money installing these systems, and for it not to be a total headache for them. Because I've seen contractors who do this work and they're like, this is a nightmare for them. And like, it shouldn't be that way.
Well, let me give you a follow-up to that. So what's the best method to support them? What can we do?
I'll let other folks sort of take it from here.
I think people like Rand we need to focus our support on the supply chain, in my opinion, because Rand is the one who knows all of the design engineers in Seattle and knows all of the primary contractors, and he takes them out to lunch. He takes them to the ball game. He teaches them about all the new technologies. Like, they trust him. And those key distributors, product reps scattered around the country, if we focus our support on them and support them, that's our little army of trainers that's already going out, already has all the relationships, already knows all the designers, and they're the ones that when the thing breaks, they're the ones that feel the pain, right? In addition to the plumber, whoever sold it to them feels that pain. And so I think the critical piece in this market transformation is that supply chain.
And note to self, next time I need a reference letter, ask John to write it. I'll say that there's a sort of a virtuous cycle here too, in that, as John indicated, if there's a problem, certainly the installing contractors are going to get angry phone calls and all that. But the label on the side of the unit that's there, is going to lead them back to me at some point along the way. And so having had experience with sort of, let's just call it a version 1.0 of these designs in the Seattle market, I personally spent a lot of time in garages and on roofs, et cetera, trying to commission and figure out what's going on with these types of systems. So we learned that it is in our absolute best interest to take control as much as possible of the design, and even the control and operation. So we learned that, boy, it really does make sense to have our package controls on these systems so that we can tie in from a laptop somewhere and see what's going on remotely, as opposed to having to send a tech out there at $300 an hour or whatever it is to babysit a unit to hopefully catch it do that one thing that the people are complaining about. So from that standpoint, that yes, I think there is a lot of responsibility on the manufacturer's branch of this particular tree. And I think that enlightened representatives and enlightened manufacturers are going to do as much as they can to create a VRF-like delivery where as much as possible is sort of driven by the manufacturer itself. There are still complications with that, and of course, every equipment rep out there isn't set up the same way and don't have the same capabilities, et cetera, et cetera. But that is, I think, a strong component in all this. The other part of this is that as people start doing this and start designing these systems and installing these systems, more and more, it becomes less of a learning process and more of just, oh, that's the way you do it, right? So some of the things that we ran into early in applications here in the Northwest, some of the, let's call it rookie mistakes that were made in either design or installation, a lot of those seem to be going away just as people get more and more used to this, and the industry itself understands these systems and how to apply them.
Yeah, if I can just jump in, there's just a related question about bringing awareness to programs that are running across the different utilities and the pilots that are running. Just a really question about how can we bring awareness to these programs for faster adoption and help make the link between the installing contractor, the implementer, and the manufacturer reps. So just ways to make those connections and bring awareness to that.
I think that's a really good point. And I was thinking while people were speaking, the intellectual horsepower that we have on this webinar is quite lofty with 96 super smart people engaged. And so I welcome some answers in the chat too. So I know that we'll be keeping it afterwards and looking at it. And so please offer your thoughts on these issues too. And I have a question that I'm not sure we know the answer to. And I'd be interested in some novel concepts, but I think what Nick said about, geez, the plumbers, they're going to bail. They're not going to do this. They're retiring. And so our workforce is getting smaller and smaller. And I like the idea of John's approach saying, we got to support Rand, because Rand is train the trainer. He's boots on the ground. He's selling the equipment to the designers, contractors, building owners, etc. So I'm going to turn this to Rand and say, Rand, what support do you need? What would make you more effective in your distribution of these, I'm going to call them packaged systems, not just bits that people are going to assemble? What could we do to support you if you are the crux between, Clone Rand, someone said, if you're the crux between a successful purchase and installation or one that gets callbacks and is very painful and is actually, I would say, in my opinion, is a scar on the industry. So we need super successful installations. I know at Bonneville, we're monitoring all these first installations very, very closely at a cost to us, because we want to make sure that in the region, these are successful. We don't want a bad installation. Bad installations give bad stories that live on forever. We want good installations. So what can we do to help you, Rand?
Well, so looking in the notes here, kind of popping up the comments coming up in the chat. One of the things that comes up is the EcoSizer product that John's group put together is a huge tool in that, because let's face it, if you're doing a gas system or any system where generation is cheap, it's easy to avoid a lot of problems by just oversizing your system as much as possible and get you through whatever issues you have. You don't need to worry too much about storage, etc. Going with a heat pump approach where generation is expensive, takes up space, etc., has all these different complications with it. It makes it much more critical to have your sizing as precise as possible to avoid costing yourself out by oversizing. And also, quite frankly, there are a lot of operational issues associated with oversizing heat pump equipment. So you really want to have this thing as close as you can to fine tune. So a product like that, or at least a utility like that, is extremely useful. I know it's well used and well understood up in this part of the country. What I don't know is how it's adopted elsewhere, right? Is this something that is well understood and well adopted in other parts of the nation? I guess the other thing is, talking about utilities and utility programs and rebates. I would say, if you're a rep of this type of equipment and you're not keeping on top of that stuff, you're really not doing your job. But at the same time, there needs to be engagement from the utilities with this group of this portion of the industry. There needs to be active engagement, updates, keeping people involved, doing seminars like this to make sure that those of us who are on the application sales side are aware of all of the options that are out there. Because there can be quite a few even in one territory that you serve. And in my case, my company serves BC, serves Oregon, serves Spokane, serves Seattle, serves all of the areas that are in between Spokane and Seattle. There's quite a few different utilities and jurisdictions that have different programs and incentives, et cetera, in those. So as much engagement as possible with this group of people, my group of people, is of course valuable. And of course, that outreach does have to extend to owners and to engineers also, because everybody needs to be engaged in this and understand what the levers are.
Thank you. That's a really good point. And I want to reiterate something that you said and brought up, is that there is a website that's under development and is newly launched called Central HPWH.org. So the acronym CHPWH.org, that has tools on it for sizing, for modeling, and other useful information, case studies on these heat pump water heaters. I will say, in my own service territory, which happens to be where you guys, Rand and John, are, we've actually had multiple projects that did not use EcoSizer. And they were sized according to, the mechanical engineering designers' best use of skills. And we have come in and kind of QC'd those projects and tried to understand, and consistently making improvements to the concepts of sizing using the EcoSizer, and kind of bringing down or adding more variables to hopefully bring down first cost. So thanks for bringing that up, Rand, and thanks for putting that in the chat, Joe. Is there anything in the chat, Helen, that you'd like to raise, or I'll pause, Nicole, also that you want to add? Like, who do you think is most important that we need to be supporting and educating? And how? How do we reach them?
I can put in a quick plug, actually. So working in New York, we work with NYSERDA a lot, and NYSERDA has put a lot of funding towards training, and that's training a lot of different people. So our firm has big training contracts where we're developing and delivering content to property managers, to maintenance staff, to supers, to installers, and we have one, particular contract that we're working on where we are working with a team of different mechanical and plumbing contractors and a local service and a local heat pump rep in our market, and doing a pretty holistic training and hands-on training with actually installing a unit in their in the showroom, and then supporting those firms in the field with their first installations. And that's like a really holistic, full life cycle, training, pre-project sale, kind of helping qualify that lead, being in the field, starting it up, M&Ving it, making sure it's working right, having, our firm as engineers, as consultants, having NYSERDA involved, having the rep involved, having all those different pieces of the market involved. We also have another firm that's working with us that specializes in community and resident engagement. And they're working with the owners of these buildings. They're working with the residents in these buildings. They're figuring out, how do we have equitable sharing of savings? How do these benefits actually even confer to residents in the buildings? It's a really holistic view, and NYSERDA is supporting all that. It's something that the market would never bear on its own in its current state. But it's a really nice way of thinking about all those different pieces and getting everyone working together and learning those lessons together.
Thank you, Nicole.
Kashmir, there is, I think, an important question in the chat that we should address, and this is, are package systems the way to go? Because the contractors could be losing their markup. It could be seen as competing with the old way that they did things. So I think part of that question really is related to why we think package system is the way to go. What are the liabilities for contractors? What about the lost markup that they're experiencing? So John, I know perhaps you could address some of these.
Well, it's certainly not going to be the solution for every building, but any complex system that you want to deploy over and over and over again and want it to work the same way over and over and over again, it's going to be a lot easier to make that happen if it's prepackaged. I mean, a residential heat pump water heater has all those same components. It's got a compressor, it's got a storage tank, it's got a control system, it's got a way to manage temperature maintenance, but it comes in a single package, and a plumber just sticks it in and plugs it in. And nobody complains about that, taking away the plumber's job of assembling all those parts and pieces in the field. Like, it's not necessarily the plumber's job to assemble all the parts and pieces of a heat pump system. So I could see maybe, I mean, the plumbers always think that they can do it cheaper themselves in the field. That is true. But I think there is a role, there's a place in the market, a fairly significant place in the market for prepackaged systems.
Yeah, and just if I could jump on that real quick, the one of the big things that prepackaged systems, the advantages they bring is now you, as we like to say, you only have one neck to choke, right? If something goes wrong,
Right.
Everybody can point to the guy who provided that piece of equipment and say, fix it. Whereas, in most of these built-up systems we've done, the first thing that happens when you get on the job site is you're trying to figure out why it's failing. And so there's quite a long process that's involved in troubleshooting and figuring out what is the mechanism by which this system isn't doing what it's supposed to be doing. And that could have anything to do from design to install to equipment failures, and nobody knows
to
for
a
long
maintenance
period of time.
person coming in and turning a valve and then forgetting to unturn it.
Right,
I have seen that in buildings, and it's really hard to figure out. But if that's all in a box, it just doesn't happen that way.
Yeah, so one throat to choke is a very valuable thing in this in the adoption of something that is seen as sort of risky technology. Being able to have that is a significant advantage.
I like to stretch the definition of what a packaged plant is a little bit.
Mm-hmm.
Like, I work in a market where we're not bringing in a skid, but John and I have talked about this before. He has had to break it down for me this way, that maybe it's that you're buying a plant design, not necessarily all those pieces pre-piped on a skid. Maybe, those pieces are just already kind of pre-configured. And if you look at like any typical gas-fired water heater commercial boiler out there, if you read through the manual, there's like diagram after diagram after diagram of this is exactly how your plant should look if you have 2 boilers. This is exactly how your plant should look if you have 3 boilers. Those plants are already pre-packaged to some extent. There's a whole page in that manual that says, this is exactly what make and model of flue to use. Here are the part numbers. This is what pump you should use for your boiler circ. Here's the part number. The controls are on board on the boiler. It's pretty much it's pre-designed plant. It's right there. Yeah, it is a kit. And so I think what's actually being proposed here is pretty analogous to what we already have for boilers. And that's an important distinction. The other part of this question that was asked that I think is a really important one is that the poster said design is the bigger issue, not necessarily the installation piece. So, and they said engineers are more motivated to learn, in my opinion. I can tell you, to me as an engineer, the biggest concern, and I've done these designs, I've peer reviewed a bunch of these designs. I think the concern is that you don't know what you don't know. And there are very few people who are really talking to every firm out there who's doing this work, who's really learning all their lessons learned in real time. And I see a lot of engineers who are really excited to learn how to apply this technology and who are doing their best and who are digging into, the specifics of a specific make and model, but they don't have the experience to know what's not written in that manual.
And they shouldn't have to make the same mistakes that we've already made.
Exactly. Exactly. So yeah, I think it's an issue of you don't know what you don't know, and not everything is spelled out as clearly in these manuals as it is for like a boiler plant. And really, we just want to get to that place where the documentation available in the industry is more analogous to what we already are used to with boiler plants.
Thanks, Nicole. That's a great point. And I like that idea because that's what I would see the qualified products list as, is that we have complete system designs there, which essentially are a package system. So I think it'd be fantastic if we could continue to fill that out with more manufacturers, more products, and then supporting Rand in repeating what we say to the people that come to him. So really good points. And somebody just noted, I saw it popped up in the chat, a design certification for these systems, so definitely, I almost wished that Rand could say, well, are you actually qualified? Can I QC that design before I sell it to you? So, so that we could really ensure that the best we can at the highest level possible, right? So we want to be able to come in at not the level where you have to touch 10 times more people than if you can come up to, for example, the supplier, the distribution, who's working between the mechanical firms and the installers. So Rand, you're the single throat to choke.
Yay.
Okay, so I'm going to go to the next.
This isn't the message I really was hoping that this we would come to, but okay, I'll take it.
I think that's what you laid out there for yourself. But we're glad you're here, and we're glad you're willing to step up in that role.
Kashmir, I want to point out it is 10 o'clock. I don't.
So this goes for another 15 minutes.
Okay.
This session. It goes for 75 minutes is what I was told.
Okay.
So thank you very much. I have another question, and then I will turn it to Helen. And this is really having to do with not the how do you size a system. I'm trying to have your answers be avoid this pitfall that I have seen. So based on your experience. So I'm a new client. I've got a boiler that's failing. I have some options here to kind of replace that boiler. I have some other improvements I want to do to the building. What do you say to me to determine whether or not the project is really the best application for a central plant? What are some of the things you would consider if I came to you and said, I don't know, I just need something cheap that's going to keep my tenants happy?
If you're looking for cheap, you may not be looking for a heat pump water heating system.
I'm just being realistic as a developer. I need to keep as much money in my pocket.
Yeah, I would also ask you, like, what are the regulations that you're going to be facing in the next like 10 to 15 years? Like, if your building is in New York or California or other places, like if that boiler breaks down, like, are you investing in something that's going to be a stranded asset? Are there incentives available now that may not be available once gas equipment is no longer allowed to be installed? So that could play into it. I'll let others speak to some of the specifics, but I would sort of start with like backing up a little bit and sort of talking about some of the like context of like where we are in the trajectory of things.
And I guess the other thing that I'd always be interested in there is looking for other targets of opportunity. You know, for example, the big issue that we talked about previously with bringing in a heat pump water heater to an existing project is you probably don't have the electric load necessary to drive it, right? Or at least you don't have the panel space to put that in. But okay, your boilers are dying. Is your chiller dying too? And if so, you know, can you do double duty with a piece of equipment that can you know, provide double advantage? Because one of the issues with making these things pay is the effective COP. And if you can get work on both sides instead of just throwing away all that cooling that you're doing and into the atmosphere, if you can get it on both sides, now your COP, you know, doubles approximately. So looking for related opportunities in that application probably helps. Not just on, you know, the utility side, but also in space, right? Because a lot of times you're going to be limited on space in those types of applications.
Good, good. Nicole or John, any thoughts?
I think the answer depends a lot on where you are. In Washington State, there is no good excuse for installing new gas equipment in any building, period. The state of Washington has passed a law that says we will decarbonize buildings by 2050 and are implementing various measures to increase the pressure on existing gas systems. So we have a building performance standard where you can only use X amount of energy per square foot for different building types. That's going to ramp up over time. So even if you think there might be a cheaper way to get something in that makes hot water, it's going to be a bad decision in the long run. Now, maybe there's certainly buildings where just an electric resistance water heater makes more sense than a heat pump water heater because you don't actually use a lot of hot water. An office building for hand washing or for, you know, kitchen sinks. that's probably should just be an electric water heater if you're, just using 20 gallons of hot water a day. But any building, and again, this is Washington State, electricity is cheap. But any building that uses a significant amount of hot water, heat pump water heater is going to be probably the right answer. And we have enough different ways enough different products to fit just about any building.
Thank you. Nicole, any thoughts in your space constrained,
It's probably different in New York.
dense New York
It is.
environment?
I think two things. I mean, in New York, again, the economics are so rough on these projects that if you give a client an honest answer on what you think the economics are going to look like, you're going to have a huge rate of attrition, and we see that.
What about future economics and risk associated with increasing price of gas? There's a big question mark out there of where that's going to go and how fast. Even in New York.
So we have a couple issues. I mean, one is like New York City today, roughly 2/3. I haven't looked at the numbers in a little while, but it's roughly 2/3 of our electricity is coming from fuel sources, and that's changing. We have legislative mandates to change that, but it's not changing tomorrow. And how much it's changing within the lifespan of a 10-year or 15-year appliance is kind of hard to say. It's probably not enough that you can in good faith really say that that's going to change the math on buying something today. We kind of have to, like, I think to Kashmir's original question, how we would decide if it's a successful project is really deciding, we don't make that decision. Like, we try to steer the client. We talk to the client about not just what are the economics today, but what are your big picture goals? What are the, potential non-energy benefits here? What kind of value do you place on decarbonization beyond the actual dollar value that our, legislation places on it? I have some clients who have one idea of where future utility rates are going to go, and I have some clients that have a very different idea of where those rates are going to go. So I might have two almost identical buildings with very different ideas of what the cost benefits look like, because they hold their own kind of fuzzy math for all those pieces that we can't actually calculate. So I think that's a big part of the decision making, and frankly, the market is not booming for this work today, so we can be a little like picky and choosy about which projects we go with, because we are still very bleeding edge in New York. We don't have a ton of installers with experience who can really, scale this work right away. So we have those conversations and we see who chooses to kind of take which view of the future today.
Thank you. Thank you. So recognizing that we are short on time and we still have an amazing group of really smart people, I'm going to ask a question in the chat for people to respond to, and then also, open it up for other questions to the panel. And Helen, maybe you can help facilitate that. But the question in the chat that I want to ask the folks that are still on the session is, what tools or research do you think that we need to work on next to tackle central water heating? What tools do you guys need as policy, program, engineering folks? I'd like some feedback in the chat. And then if you'd like to ask a question to the panel, maybe raise your hand, and Helen, you can help facilitate that.
Sure.
Do we have any hands raised?
I'm not seeing any yet.
Rand, what tool would you like to see? What would you like to see more of to support purchasers of the products you're selling?
What would I like to see? I would like to see Washington's policies adopt across the country is what I would like to see. But, because I mean, I'm being a little facetious, but let's just put it in my experience, the understanding and the maturity of this market has increased significantly in just the last few years in terms of the customer knowledge, the engineer knowledge, the manufacturers. For a while we were like the only guys really in this market, and now there are, mainly as representatives in this particular market, and now there's several people who all are providing good guidance and good support to this industry, and so that obviously makes it more challenging for us to stay on top of it and stay relevant and all that, but that's what our job is supposed to be. So I don't mean to be too terribly facetious about that answer, but that obviously helps. Policy is a big driver in this. As far as what else, I think we talked about a lot of things that really help us as vendors in our role in adoption, right? And that is good knowledge on programs and incentives and rebates and all those sorts of things that happen on the utility side, as well as a lot of the tools that the John's group has put together that create sort of a more standardized approach in the industry-wide to these systems to make every job not starting from scratch. That there's sort of a understanding, hey, this is the standard way this is done, and yeah, this job needs a little bit different here, and we'll tweak this here, but this is how we do it. And that's kind of what we already have with gas boilers. People know this is how it's done. As Nicole was talking about, all the manuals all have these plants all planned out already. Everybody kind of knows that's what they need to expect. I'm not saying that it's impossible to screw up those systems too, but generally there's an understanding amongst the installers, the building operators, the vendors, and the engineers of how those things are all going to go together. So everything we can do to create sort of an industry-wide expectation of how these systems are going to go in helps in our application on future projects.
Thank you. Helen, do we have any hands raised?
Yes, we have one hand raised. Let me see if I can unmute, if I can allow the mic and the camera. Okay, go ahead. I think you should be able to speak now, Gary.
I believe that's accurate. Thank you. So what I'd like to ask about is how do we get better sizing and better distribution, understanding of the distribution losses as part of the sizing problem. Methods we use for sizing are, I don't know, they're almost as old as I am. And we're still using the same rules of thumb, and most engineers don't know about an eco-sizer. And they're still sizing regular equipment using old rules too. So everything is just weirdly sized, in general oversized. And then John made a point earlier about putting an electric resistance water heater in a bathroom group. That would eliminate all the distribution losses that we currently plan are necessary. How do we deal with that? That's a question that I think we need some information on to better sort out what we need to recommend. So that's something I'd like to see if that's possible.
Yeah, I think that's a great point, Gary. I mean, we made the eco-sizer because the standard existing ASHRAE approach made a lot of sense. If you, like Rand says, you can just upsize that gas line a little bit and blast it with a lot of gas, and it's easy. And so the sizing is not that critical, but when you're selling heat pumps, it gets to be pretty critical. And the parts that, so EcoSizer, I think, does a great job of sizing for multifamily buildings, the water usage. The temperature maintenance load is a big guess. It's our best guess based on what we know, which is not a lot. So some research focused on how do we actually calculate and reduce that temperature maintenance load in these buildings is super important, and developing a calculator that could support the industry on that. And then the other thing I would point out is we can do multifamily buildings really pretty well because they all kind of look the same, but the other commercial building types still are using these load shapes that were developed when Gary and I were born, and things have changed. And so we need to do research on to update those other commercial building load shapes so that we can adequately support them with the EcoSizer.
To just do a time check here, we are just now at 10:16 Pacific, so we are at our time now. We will be sending out a recording, so everybody can all the questions.
Thank you. And thank you for those that put in the chat the answer to the question that what tools or additional research is needed. So I know that we'll be definitely looking at that as part of AWHI and the Central Heat Pump Water Heater team. But with that, since we are a couple minutes over, I just think everyone should give a round of applause to our great panelists that endured our session today and shared their knowledge. So thank you very much for being an awesome, awesome team. And thank you to all our participants. I think I saw we were like 95 people, 96 people in. So super big round of applause for all those willing to come and listen and learn and share knowledge too. So thank you. And be a heat pump water heater superhero. And remember the tools that you have.
I got to remember next time I'm out on a site to take a picture of myself hugging one. I don't have a good picture of one of those.
Have a great day, everyone.
Bye-bye.